Welcome to our next CAD workshop for xDesign, part of 3D Experience Package. This one is on imported geometries. And imported geometries, what they are, it happens when you import a CAD model from a different CAD package. Every CAD package kind of has its own native CAD format, and there's a few universal formats that allows you to import from different systems. And depending on what you're trying to do, there's some formats are optimized for different types of applications. So meshed files, such as STL and OBJ files, object files, are constructed from a number of triangular facets. And it's a really good choice for 3D printing because the 3D print, there'll be enough detail in there to get a really good representation of your model. Sorry, dialogue just popped up there.
Yeah, keep going, you're good.
Okay. Yeah, so it's a really good representation of the model, but it's not a perfect representation, which is kind of the nature of 3D printing. So it's a really good choice if you're going to 3D print it, but not so good if you're going to import it, because now you basically, it's kind of like importing a JPEG into CAD, where if you zoom in onto the model, you'll start to see little triangular facets, just as you would pixels. So there's some files called neutral files, such as a parasolid, which would be x_t for the text parasolid, or x_b for a binary, a step, or 3D XML, which is the 3D XML is what xDesign tends to like. And that kind of maintains the geometry. So if you have a circle and you keep zooming in on the circle, you'll never get down to individual triangles or pixels. It'll always remain a circle. But however, even though you've got a good representation of what the shape looks like, we lose our feature history or our feature tree. Every CAD package is going to kind of represent extrudes and cuts and fillets and chamfers and all those in a different way. So we'll still get a model that looks and acts exactly like the original model, but we can't backtrack back to the original sketch or any of the exact features that we created. But what we have instead, we've got a new toolbox, and it's basically we can take every little feature on it becomes a face, and we can start pushing and modifying faces, or you can even sketch on those faces too. And what it'll do is it'll reference itself as an imported body. So instead of having a part with cuts and extrudes, and you just see one imported body, and we'll have to work with that instead. So here's a good example. What I did is I drew a cube and cut a hole in it in SolidWorks. I saved it as a SolidWorks part file, and xDesign can actually import the SolidWorks part files kind of in that format, but we don't get it as the actual like rectangle and the extrude and the circle and the cut. Instead, if you look in the feature tree, we see an imported body, but we do see an exact representation of the part. So say if we wanted to edit that, the first thing we have to do is tell that imported body that we want to direct edit it. The way we do that, if we right click on that imported body, there's a little icon that kind of looks like a cylinder with a little face that's being stretched up and angled, and that's the direct edit icon. So once we enable that, we'll be able to take and start modifying and pushing those faces around. But as part of the conversion to direct edit, it can do some things a little bit smart. It can recognize fillets or chamfers. It won't do it 100% all the time, but for most of them, it'll do a good job. As you can see in this model we brought in, there's no fillet or chamfer, so I'm not going to check that. We won't bother trying to recognize them because we know it won't. And once we have it in, we can translate and offset faces. So what we'll do is we'll translate the right face and grow the part by 10 millimeters. Then we'll offset the whole. So an offset is a little different than a translate. A translate will move it in one direction, whereas an offset will kind of move it in all directions, so that it have the net effect of growing something or shrinking something. So we'll offset the whole to shrink it by 2 millimeters. And just to show that we can still we can sketch on that part, we'll add fillets and emboss to the top face. So once we have the part in and converted to direct edit, you can see there's a little move face, which looks exactly like that. We've got a rectangle, the face highlighted blue. So we click on that. And from there, we're able to select the face. So in this example, you can see I selected the face on the right. We get the little white arrow that we can push and pull to stretch that part or that face in and out of the existing part. And we also have a distance. So what I did is I typed 10 millimeters in there, And once we hit OK, you can see that our part, even though it wasn't a native xDesign part, we were able to still modify it. And if you look in the feature tree or the design manager, you can see now that we've got this move face link, or this move face history link. So we can actually edit that. We can change it to 12 millimeters, 10 millimeters, or whatever we like at a later point in time. So rather than moving a face, let's try offsetting one. So if we were to click on that cylinder, and for the move type below, you can see right now we changed it from translate to offset. I typed in 2 millimeters. The arrow is pointing in the direction we're going to do it, which is shrink. It's offsetting in. We could also reverse that arrow and offset it out by clicking that button. And you can see that hole looks like it's got about 2 millimeters smaller. So once we confirm that, yes, it's a little bit smaller. From the top, we can add some fillets, whatever we want. You can see it starts building up that feature tree. So we've got the direct edit, we've got the move face 1, we've got the move face 2, and we added a fillet. So the next thing we want to do, let's make a little circular boss on this side too. We'll make it 11 millimeters away and on center line with this one, and make it equal diameter too. So, and here I tried to sketch on this front face because the face of an imported body is a valid place to sketch on. I drew a circle, and if you look at the, you should be familiar enough with xDesign now. You can see we've got some constraints here. Here and here are horizontal constraints, which means these two center points are horizontal. You see two equal constraints, which means the diameter of this is equal. So this is almost a fully defined circle. The last thing we had to do was give it a center distance. And with that, we'll be fully defined. So if we just say, okay, we've got the fully defined circle, let's extrude it by 5 millimeters. You can see that we've actually done a pretty good job modifying this imported body. It was pretty easy. So even though we didn't have the native geometry, we were still able to do it. So that's kind of a quick introduction. So let's apply this technique to the Elegoo car that was imported from the SolidWorks model. While we're in there, we'll look at kind of isolating a component, because a large assembly can get pretty complex, pretty messy. There's a whole lot of parts in there. Sometimes you want to just work on one part. Often if you're working on a mounting plate or something like that, you want to just see that mounting plate. We'll insert a new component in that assembly. We'll reference geometry from that original imported body to build a new component. And I'm also looking at how to export it for 3D printing. So I'm going to exit out of the presentation now. I'll go into the xDesign, which I've already got started up, so we don't have to wait. Close out. And what I'm going to do now, instead of going directly into xDesign, I'm going to show you one of the ways that you're able to import stuff. What I did is I went on a website called GrabCAD. Someone had already drew this whole model in SolidWorks, and they shared their design. And you're able to download that design. And if we had SolidWorks, we can import it natively. But there's a number of ways to get into xDesign. And if anyone has any questions, we can do another workshop on that in itself. But I think by now you're probably going to be familiar enough with xDesign that just giving you kind of these tips should be enough. So as you can see here, I clicked on my 3D drive. What a 3D drive is, it's kind of a space up in the cloud where you can upload files and choose who you share them with. So I downloaded the whole zip file from GrabCAD and put it here. And you can see it's kind of redundantly named folder. There's one called Elegoo in the Elegoo folder. So if I click that, here's all the parts that someone drew. You can see every part of the Elegoo car is here, and including the SolidWorks assembly. And again, we're not going to be able to import it as a native design, but this is probably the most efficient way to get it in. From here, I just created a new folder and I uploaded that all those files to it. And from there, I was able to import the whole design into xDesign. So I'm going to click on xDesign now and start that up. And that 3D drive is kind of a nice way to share files between other xDesign users or 3D experience users, I guess would be the more proper way, because the 3D experience is the package that kind of involves everything. So what I did here is I imported the file. Let's see if I can just show you quick here. It was in my 3D drive. I picked a SolidWorks assembly part and I imported it that way. But I'm going to cancel out of that because it takes quite a while to get all those parts in. And you have to trust me, that's quite easy to do. You should be able to do it yourself. So what I'll do is I'll open instead, because I've already have this file converted. And its file here is called Elegoo. So instead of clicking on the name, which will bring up a viewer, I'll click right on the model and it'll open it up in xDesign. Now, when you open up an xDesign, it's going to be kind of a great, giant, kind of monolithic structure. There's not going to be sub-assemblies. It's not going to be mated or anything like that. So one of the first techniques you might want to do is kind of group some parts and create a sub-assembly. And even though the proper way would be go in and kind of take advantage of some of the mating things we did in the previous workshops, you can also just fix components in place as well too. So here we go. Here is the Elegoo car. And if I look over in the design manager, you can see all the different parts in here. There's the different wheels. And you also see something called the car body. So the way I did the car body is I picked all the components that weren't wheels or the cup, and I grouped them. And the way you do that, if you were to click the 4 wheels, and if I was to right click, there's one here with a little plus, where I could say form subassembly. And once you form a subassembly, it'll give you a high level assembly name. And in this case, I called this one car body. So if I click on the arrow now, you'll see why I did it. Because now every one of these screws, as I scroll around here, let me hit escape so I kind of unhighlight a lot of stuff. Every one of these screws, as I scroll around, is a component, as well as all the motors and top plates. And rather than mating those each individually, because I doubted I was going to change any of those, I just hit fix and I fixed all those components. But what I did do is go back in and mate the stuff that I might want to see motion on. For example, the wheels. If I click on a wheel, if I can grab part of the wheel without grabbing something else, it can be a little tricky sometimes to grab just a single part. So you have planes and such that you're going to divert to first. There. So I grabbed a part on the wheel. You can see I can rotate the wheel. So I went through and used the same techniques that we talked about in the last workshop for mating. The ultrasonic sensor here, I mated that to the servo. So that rotates now. It kind of gives you a feel for what you should be doing with your models and how you should be using the previous workshops. So I did a bunch of changes last night, but it looks like they came back. So what we're going to do, let me see if I can hide this part here. Let's just dive right into it. So say if we want to work on something, say if we wanted to make something for this top plate here. In a big assembly, it's going to be hard to figure out where this is in the feature tree down here. There's probably 100 components or something in this. The one thing that's really nice, if you hover over it so it's highlighted and you click it, you can see here it automatically jumped to top plate. So I can click down and see what the top plate is. And I've got some move faces and extrude cuts. So this is something I did last night. I'm going to do, can I delete that right now? It's not letting me, oh, I have to activate it first. Okay. So one of the things we can do is, there's a lot of stuff on here. There's a lot of information going on. What we might want to do is kind of break that down a little bit. So if I right click here and look at the different options, we can show, hide, make it transparent, apply material. But this one here is isolate. So the two ones you really want to focus on here is isolate. We'll turn everything off except this component, and this is activate. In order to be able to work on the component or delete or do anything to it, we have to have it activated. But for now, let's just isolate it and we'll see what happens. Okay, you can see now everything else in the component and the drawing is turned off. It's still on the feature tree, but it's grayed out a little bit. And it's still not activated yet. So I can go to the top plate and I can hit here and activate it. I could double click on this. That would also activate it too. Sometimes it's nice to use the menus just so you know exactly what you're doing. Double clicking can sometimes be a little bit sloppy. Okay, so we go back to our Elegoo car in the design manager here. You can see a lot of stuff is grayed out, and not just the components just aren't grayed out, but the whole area is grayed out above and below. We have this white area right here. That means this top plate right now is activated. So we're able to go in here. I made some changes last night when I was trying to figure out what I wanted to do for the workshop. So what I'm going to do, I'm going to go through and I'm going to delete these changes. Hopefully that works, and hopefully a bunch of stuff disappears. Okay, and I'm gonna actually delete this. There. So this is back to the original base plate. So this is the top plate for your car. If you're doing any mounting, this is probably where you want to do it. So to try and talk a little bit about what we just did in the workshop, to give a practical example, even though we can't change our physical parts that came with the Elegoo kit, I'll kind of show you how to do it just to compare. If I look at the top plate here, you can see this little direct edit here. So it's already been direct edit's already been turned on. So since it's already been turned on, I don't have to do it again. But what I can do now is go to features. As we talked about, we've got this move face. So I'm going to turn that on. And it comes up here, select faces to move. So let's make this flange a little bit bigger. Okay, it's being a little slow, so let's try this again. I'll click one face, two face. And I'll zoom in a little bit. There we go. If you find that you're having trouble selecting a face, just zoom in a little bit. Sometimes with all the triads and stuff that are in place, it might get buried. It might be hard to select. So now you can see up here in the faces to move, I have three faces. It's translate is selected right now, but let's say we want to offset that. Pick offset. And here we can now grab the arrow, and you can see it starts to make this whole thing bigger and smaller in all directions, which is kind of cool. I can scroll it out here and drag it to any size I want. I could type in the box, or if I move on this side of a little ruler, it's going to snap to some different hard numbers, so 10. So I let go there, it'll offset at 10 millimeters. And if I were to hit yes, there, you can see we've now modified that plate to be a little bit bigger. If we want to make another mounting hole, we could do, let's go back down here, we'll hit sketch, we'll draw a circle. And again, it's asking us for what plane, so we can use this mounting plate, top face as a plane. You can see we've got, it's turned the grid on, so it means we're in the right place now. We're actually on that plane. And again, with most CAD packages, they're pretty context sensitive. So if I know I want to make this relative to the center line, I kind of move over here. It kind of wakes the CAD up. It knows, oh, he's interested in that center line now. So there, you see that little light arrow there? So I just drew a circle there. I'm gonna hit escape. Actually, it didn't. Okay, so it didn't actually make it coincident. So if I want to make the two center lines coincident, what I can do, I'm gonna take a point and I'll drop it in the center of this. It allowed me to drop a point in the center of that. So now what I can do, I'll select the point, select this, I'll let go, and I think horizontal is what we want. Yeah, because if I hit N for normal, zoom too far in. Okay, now I might be in trouble because I don't know which way to zoom, or it zoomed in some really weird place. Okay, so I'm going to exit out of that sketch. Okay, I've lost my model. Let's go to view, and there'll be one here to view extents. Reframe. Nope. Zoom in or out. Okay, so this might be a little bit of an xDesign bug. So I'm going to exit isolate. We can come back in. It's kind of good sometimes that these things happen to be able to see how to recover from it. There we go. We could have probably just used the triad to select, or the little front view selector. Okay, so you can see now we still have our part there. I see it's this white, so I know it's still activated. So what I'll do again We'll go back on here and I'll isolate it again. You can see how everything was grayed out. Once we activated, everything grayed out, but sometimes it's nice to have just a really clean part. So sketch, we're going to make a circle. We're going to make a circle. So we have to pick the face. Make a circle there. Okay. Zoom in. And again, we'll put a point. We want to make the point. There it goes. Make the point coincident with that circle. We'll hold down Shift. Select these two. Gives our constraints. We'll say we'll make them horizontal with respect to each other. We can click the diameter of this, hold down Shift, click the diameter of this. So we want them to be equal to each other. Ruler, say from center line to center, is 10 millimeters exactly. And now we can go feature, and we want to do an extrude, and we're going to cut that out. So there's a cut, blind. Now we can say up to next. And those profiles, what if we hit OK there? There. So you can see we modified that plate. Again, even though we can't do that for Elegoo car, gives you an example of something you might want to do. You know, if you want to reference some of the holes here to make a little mount. So because this part's a little off to the side, what we'll do now is kind of show one example of how we might want to use the geometry in here to do some referencing. So what I do right now is I'm going to deactivate this part. I'll keep it isolated, but I'm going to activate the whole Elegoo car. So which one's you activate again? Activate. So I'm going to activate the root assembly. And what we're going to do now is we're going to start to learn how powerful xDesign can be when you kind of step outside the kind of standard part assembly constraints that current CAD has. A lot of the cloud-based software now is throwing those things to the side. And there's a really grayed line as what's a part with assembly. You kind of treat them all the same. So from one of the earlier workshops, we talked about components. So what we're going to do now is we're going to insert a new component, and this will be a new part that we're going to make a little bracket or something like that to 3D print. And the reason why I want to activate this Elegoo assembly, because then this will be a component in the root of this assembly. If we would have done it while we had the plate activated, it would have been a kind of child of that plate. But we want a new component to be a child of the main part. So we go to assembly. And if you remember, we had in the last time we made our little linkage, we were inserting an existing component. This time now we're going to insert a new component. Let's call this mount. We'll make it a mount for something. We don't know what yet, but we'll make it a mount for something. Okay, I could have told it to move the origin, but that's not really that critical at this stage yet either. I could have put the origin at the center. So now if we look down at the very bottom of our tree, we've got something called a mount. And this component is still isolated, so we only see that and not all the rest. But anything we do will be part of this mount now. So we double click the mount, we'll activate that. So now the sketching we're going to be doing is in this mount component. So rather than making a new component, making a new assembly, and making a new part, you can see we're working just in the feature tree to add the new part we want right into our tree. And that's something that the cloud-based software is really big on now. So let's make a sketch. What we want to have something that kind of follows this line a little bit. If we're going to 3D print it, we want to have it a little bit offset. So say we want something kind of nested around this. So what we'll do is we'll do our use. I don't think you can offset based off this component, but let's give it a try. So sketch, here's the. Okay, so yeah, we can't offset on that on its own yet. So what we'll do is we will do a use. And here's the plane. Okay, so let's try the offset now. No, it's still not allowing to offset that. So what we can do is we'll do the use or the convert entity, depending on what your dialog is. And let's say we'll use this line, this line. You can see just by selecting that line from the other component, you can see it's turned it black. So we actually have that kind of reference. So now if this base plate was to change, this would automatically adjust. And I've drawn a box around these to select them all, and I'm going to turn that to a reference geometry, construction line, sorry. Because when we're 3D printing a part, we always want to give it a little bit of a border for shrinkage of the part, so it's never going to print perfect. You want it to fit a little bit easily. So now what we can do is I can select this line, and we had select chain selected here in our dialog box. So you can see now it's selected all these as a chain. You can see now we're going to get a new line here. That's 2 millimeters away. Let's say it's maybe 0.2. Maybe we'll give it 200 microns, 0.2 of a millimeter, a little bit bigger to get a little bit of wiggle room. Depending on what kind of printer you're doing, you'll get a feel for what that should be. Hit OK. So now if we zoom in, we've got a line that follows that contour that's 0.2 millimeters bigger. Okay, so let's do this again. Actually, it worked out so well. What we'll do is we'll offset this part now. We'll zoom in so make sure we got the right line. We click not a construction line, but a regular line. And say if we want to make a 4 millimeter wide part. So it followed that line all the way around. It's still not colored in, and we know exactly why, because we've not closed it yet. So we take a line. If you don't quite know what we're trying to do yet, you'll get it soon enough. I'm going to zoom in. We'll close the other side now. And this is why zooming in is really important. You can see how I was kind of picking the wrong point there. I was picking a construction line. There. Now you can see that colored in. So if we were going to have this kind of cup around that new mounting flange, that would be good. So what we can do now is we're going to go to features, and we'll extrude that down. So you can see it's kind of going the wrong way now. It's extruding up. We'll hit the direction button here. So we want to extrude it down. Instead of going blind, I don't know how thick this mounting plate is right now. So instead of going blind, we can say up to geometry. And for the geometry, we'll select this face. And look at that. So now you can see the yellow. It's extruded this piece from the top face down to the bottom of that. So let's hit OK. There. So now we've got the thing that little bracket cupped a little bit. So let's make another sketch now on top of this. And this will be kind of the part that rests on top of our little acrylic plate here. So we already have this geometry here, so we'll make it follow that geometry. So for that, we'll do our convert entity. It's already selected the sketch. We want to do that. We want to do that. We want to do that. Now we're kind of sketching on something we've already done. So if I angle it a little bit, you can see what it is. Now, if we take a line and close off that last little bit, it turns shaded again. So we know we can actually do something with that now. But say if we wanted to have mounting holes for the screws too, we could convert entity of this and this. And now when we extrude that up to make it have some thickness, those screw holes won't extrude unless, of course, we want them to. We'll go back to our extrude. And let's make it about 5 millimeters thick. That's good and robust for a 3D printed part. And we have it add, not cut. So we hit OK. There. You can see we made a little piece. So say if we wanted to be even fancier, we could have put a rectangle on here, extrude it up, and have another mounting place, another little mounting plate. But for now, to make this stand out a little bit, which places have fallen? Oh, the design tree here. So we can actually change the color. Let's pick this item 1. Let's make this red just so it'll stand out. Apply and continue. And yeah, I'm having a hard time getting the color to work, so we'll leave that for now. It works sometimes, it doesn't work sometimes. I don't know if their assembly is just too many pieces right now, or if I'm doing something wrong. So what's important now, actually we should have been doing this all along, is hit the save button. Whenever you're doing something, you always want to keep saving. And the part's still activated and we're still isolated. So up here, you can see our part's isolated. Here you can see, because all this is grayed out and this part is the only part that's white, this is the active component. So because it's the active component right now, if we go to the little disk and say export, what it's going to do, it's going to export the active component. So rather than doing to the 3D drive, the file on disk is a file on our local computer. So mount a.1 looks like a good file name to me. By default, it wants to export a 3D XML file, which would allow you to import into other CAD packages. You can import that back into SolidWorks. But instead, we'll pick the drop-down dialog and we'll say STL. I'll leave the resolution default, but depending on what kind of 3D printing you want to do, you can select your facet resolution for your triangles. And I'll hit export. So down here, we have success dialog over on the side. You can see down for our browser, we've got an STL. So I'm going to click that. It's a 3D viewer as the default. So if we pan around now, there's the part that we just added. As we zoom in, you can see that's what we were talking about before. It's not a perfect cylinder anymore, or perfect curve. You see the facets, which you probably won't see with a 3D print. If you want to change the resolution, make those facets smaller. But that's probably covered in one of the 3D printing workshops. Okay, so now to kind of back this out and get it to a kind of a workable piece here. One of the things we might want to do is go here and say exit isolate. So if you remember, we had that plate isolated, so all this complex stuff got off, was turned off. And now you can see why, because if we were trying to work on this, there'd be a lot of other faces we could accidentally click on. But again, as we mentioned, this one is activated now, the mount one. So we go back all the way to the top, double click on the Elegoo car, it's activating the Elegoo car. And after it's done thinking about it, there. So now we've got the whole car. And as you can imagine too, it's pretty easy to insert the cup. I can insert the cup. Oh, it's not mated, so I can mate that onto that plane if we want. And this little 3D printed part we just made, this mounting bracket, we should be able to move that around too. If we wanted to do this properly, what we could do is we could say this cylinder, I'm going to hold down Shift. This cylinder I'm going to let go. And if you remember from our other workshop, we have a concentric mate. So we can say we want those to be concentric. And after it's done thinking, face one and face two. So I'll apply and continue because we want to mate it a little bit more. So we want to do this cylinder. And let's see what's going to allow us to do this. Oh yeah, it did. So it's pretty smart. So it knows that we're probably going to want to do this cylinder down here. And now you can see it's kind of sitting in the right position right now, but if we didn't constrain that second screw hole, the part would be allowed to twist just like it would in real life. Okay, so I'm going to apply and continue because we're not quite done mating yet. The last thing we want to do is try and mate the two faces. So the underside of that should sit flush with this. And already it picked the coincident mate and knew what we wanted to do as well. It's pretty smart that way. If we hit OK, now that part is fully mated. Probably what we want to do now is remove this screw and remate the screw up here. But I think that probably gives you a good idea of how to start playing around with bigger assemblies, how xDesign kind of throws away all the constraints of being bound by a part and assembly. You can see it's all just in the design manager. You kind of treat them all equal and play around. So anyways, I think that kind of concludes what we wanted to cover for tonight. If you have any questions, please feel free to ask on Discord. And after that, thanks everyone for attending.
Awesome. Thanks so much, Brad.